We are going to be talking about L'Hopital's rule, which is to determine limits. So again, calculus is broken up into three big ideas. One would be limits. One would be derivatives. You don't need to write this down. And the other one would be integrals. And the fact is that we've spent a lot of time in this class so far talking about derivatives. That's been a big part, right? But every once in a while, we got to go back and look at limits, okay? And that's one thing we're doing now. So we look at example 8, and I want to determine this limit. What would you do first to determine this limit? It should be a t goes to 0, by the way. What would you first do to determine that limit? Plug it in. And so I plug in t, or I plug in 0, and what is e to the 0? 1 minus 1 is? Then you plug 0 on the bottom, and you get 0. So you can see in this situation that you say I get a indeterminate value. Indeterminate. Not undefined. Indeterminate. So we may be able to determine it if we use L'Hopital's rule. And L'Hopital's rule says to determine this limit, we take the derivative of the top, which is e to the t divided by 3t squared. And so in this situation, we get we plug in 0. What do you get in the top? 1. And what do you get in the bottom? 0. Now, 1 over 0, we generally say undefined. However, that's not when we are working with the limit, okay? The limit could be, in this situation, it could be infinity, it could be negative infinity, or it could be does not exist. This is not the option, okay? So that's what we want to determine. At this point, L'Hopital, as well as algebra, runs out for us. So what we need to do instead is we need to look at a graph. So take out your calculator. All right, in the top, I'm going to put e raised to the x power. So e is going to be second natural log or second divided sign. Either way, you'll produce e. And I'm going to divide that by, and I have to put parentheses in the denominator so it doesn't just divide by 3. I want to divide it by 3x squared. Everybody okay? Okay, I'm going to zoom 6. Everybody see what I'm looking at? Okay, so I'm going to zoom in a little bit. I'm going to change my window so my x min is going to be negative 3. My x max is going to be positive 4. Let me check this graph again. And there we have it. So can somebody tell me, as I approach 0 from the left, what is it headed towards? And as I approach 0 from the right, what's it headed towards? Are those the same? Yes. So therefore, the limit is infinity. If they were not the same, there would be does not exist. Yes.
So then for the number 3 on the homework?
Exactly. Please turn to your homework at problem number 3. What's the original problem, Miss Ella?
The limit of x approaches pi over 2 is cosine of x over 1 minus x.
Okay, so this is a nice problem for us. Okay, and as we determine this limit, we plug in pi over 2. Everybody here knows what the cosine of pi over 2 is. What is it? It is 0. Divided by 1 minus, what is the sine of pi over 2? It is 1. And so you can see in this situation, I get 0 over 0. L'Hopital's rule says we have indeterminate form. Let's take the derivative. So we do. limit as x goes to pi over 2 of, what's the derivative of cosine? Negative sine. And what's the derivative of 1 minus sine? Negative cosine. So in other words, tangent of x. The problem is when you plug in pi over 2 for tangent, you do get an undefined result. Or if you didn't even focus on tangent, if you just focused on this, the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So we get the same situation we had before, didn't we? So L'Hopital's rule doesn't guarantee that you'll come out with a nice number like 5 or 3/5 or something like that. But it is a strategy. When you come up with this situation, please do not write undefined. Our answers for limits in this situation would be infinity, negative infinity, or does not exist. So we must determine the graph. Do you remember what the graph of tangent looks like? Yeah, it looks like this. Okay, everybody remember that? And if you do remember, it is undefined for a value of pi over 2. So it looks like, that's the graph that it makes. Okay. So let's consider the limit as x approaches pi over 2. Let's approach pi over 2 from the left. So what am I going towards? Infinity. And as I go from the right, negative infinity. Therefore, the limit does not exist. Now, it is possible, very possible, that you could see this problem on the AP exam, and they would say, you're going to determine this limit, but you are going to determine it from the right. Then you would have a result, wouldn't you? You would have negative infinity. So please just note the difference. Kind of brings back a little bit of your thoughts on limits, Mr. Timothy.
So how would I know where pi is?
Yeah, pi over 2, pi over 2 is equal to 1.57 if you were to take pi and divide it by 2. So as you roll over on your graph, you're going to see that spot. Can I tell you how I knew there was undefined at pi over 2? So that you can have just a little bit of information, and I'll let you go to work, but so that you can understand how I try to navigate this whole idea of tangent. Tangent is, in terms of x and y, would you agree that tangent is y over x, which is the same thing as slope, is it not? So what is the slope here? 0. What's the slope here? Undefined. So slope here, 0. Slope here, undefined. So you know that tangent is equal to 0 at 0, but at pi over 2, it's undefined. At pi, it's equal to 0. At 3 pi over 2, it's undefined. And at 2 pi, it's 0. So as I cycle through tangent, the fact is I know that tangent repeats itself every pi units, and at pi over 2, that's where it's undefined. So the graph looks like this. And the reason why is because, again, this is mapping the slope. Sorry. Let me try to get you back just for a second, okay? Welcome. What's the slope like here? Small or big? Small. See how the tangent graph value, it's not very tall? What happens as I move on up? What happens to the slope? It gets bigger and bigger and bigger and bigger and bigger, right? Which is why the tangent graph continues to go up and up and up and up and up. But as soon as I get to that one vertical spot, now we say finally undefined, which is why you have that vertical asymptote. All right. The rest of the time is yours to work. I'll come around and help. Everybody has a study guide. I need to make the answer key for the study guide yet, which is what I'll be working on tonight and tomorrow. Okay? Either the first is E.